Thank you. Hi again. In addition to my roles at Deutsche Telekom and the LCM working group, as you can see, I like to make myself busy. I'm also chairing the high-level API working group alongside David, which has been playing a very important role in the progress of these activities. For today, do you have the remote?
I have the...
Okay, thank you. Sorry for that. So for today, I have a presentation similar to the LCM in the sense that we are going to use the opportunity to do a little recap on the working group's ambitions, talk about some of the problems that we are trying to solve, and of course give you an overview of the various ongoing activities. First things first, essentially speaking, the high-level API focuses in application or service development for broadband CPEs, and we have many targets, but I believe that we can summarize it in essentially 3 building blocks or 3 aspects. Starting with the one in the middle, you will hear the word portability quite often, and here we are trying to look into two different angles. Not just portability across different stacks, like you hear RDK and so on, but also different deployment environments. And that's something that we realize that it's not always clear to everybody, that we are also looking into these different aspects. Secondly, we want to address inter-application communication, the ability for these applications to interact with each other, and thirdly, also enable rapid development, because that's also part of innovation. Starting with the first one, everything starts with a dream, everything starts with an ambition. We have development teams, what they really want to do is create application services, software modules, whatever we want to call them. And they want to, these companies, they want to maximize their deployments. They want to put it out there into prpl OS compliant gateways. They also wanted to put it out there in RDKB. But there are more things. There's also closed source CPEs out there, and reality is when you're looking at this from not just from a service provider perspective, but from an actual application provider, either be it Wi-Fi management, either be it security, smart home, something else, you want to maximize the number of devices that you can put your services out there. This is what's really about the ambition. However, the reality is a bit more harsh. What we realize is that you start with that ambition, you create that application, that service, but rather sooner than later, you realize that now you have to fork that implementation, you have to do an integration for prpl OS, maybe you have to have a different integration for RDKB, maybe you have a different integration for your closed source. Sometimes even within the same stacks, you end up with different variants, and you started with one team with one big promise and realize you end up with 3 or 4 teams. So instead of having one team to create multiple applications, you have multiple teams creating one application, and that's not a very cost-effective way of driving business. So we want to help you solve these problems. The second aspect about portability is I realize this is not discussed as much as I would like it to be, is we observe a similar trend also in terms of creating services across different environments. One might think about smart home, one might think about security and so on. Some companies do it in the CPE, some companies do it in the cloud, some companies do it both, and some companies change that strategy. But the reality is that they are doing the same things, exactly the same functionality, the same capabilities, but just because they deploy it in different places they have to completely rewrite the applications because they use completely different sets of APIs. And when you think of it, that's a bit of a waste of valuable resources. So we believe that there are some things that we can also do to support in this space. I just put a little bit of an example here where we see when you typically do something on the CPE, you hear words like system bus, but immediately moving to the cloud, you hear a lot REST APIs, but of course this is not limited to these technologies. Another problem worth noting is that applications need to interact with something. And when we say something, it's usually not one component in the system. It's usually the application needing to interact with different aspects. Just think of a basic example like the web GUI, right? You want to show the list of devices, so maybe you interact with the host manager or whatever we want to call that, or you want to provide some basic Wi-Fi configuration, and then for that functionality, you interact with the Wi-Fi manager or prpl mesh or something else instead. And the reality is that you want these applications need to interact with certain parts. They shouldn't interact with other ones because they could pose security issues. And in some cases, we end up in these, I tend to call quantum states, or which they need access, but not to everything, so partial access. And the reality is that we don't have the technologies out there to solve these problems. The technology exists, but it's not widely deployed. Lastly, but not least, still on the problem statements, we talk about we need to speed up innovation, we need rapid development, and reality is that even though we have a lot of standardization in our industry, we hear the words a lot, data models, but when we start to actually talk to developers, when we actually start to recruit people to work with us, to help us make these things, we get some clashes out there. Some of these people coming from other worlds, they are probably used to interacting, writing C code based on function calls or creating some shell scripts, or if you are more in the cloud REST APIs. But reality, and then suddenly we ask them, no, you need to interact with data models, and you get things to slow down because this is not what people are used to work. You get some people get white hairs like I do. some people start to get bald. But reality is that there's a value in working this way, and we believe that we can also, perhaps there is an opportunity to provide better tools or more training to help the application developers to deliver these things. Well, so looking at these problems and the reasons why we are trying to look into space, and if you couple that with some of the industry, the trends that we see, things like data models, I'm not going to mention that again, we all know about that. We've been also discussing a lot, we need to work with more standards, we need to do open source. There's also we are moving away from this monolithic architecture, now doing microservices. Containers might also play some role here. Cloud computing is coming in, but edge computing is coming in. So when you think about these problems and also trying to do something that blends or aligns with these industry trends, we realize that there are really two options. We either create something completely new, and we usually do not get the best feedback because that leads to a lot of effort, or we try to look at what's existing and try to take it from there and extend it and so on. And that's where we end up with a high-level API where really the recommendation and the efforts that we see, you see TR181 widely deployed in RDKB, you see TR181 also widely deployed in prpl OS. But the reality is that this also creates a lot of alignment, but it doesn't solve all problems, because the way that you can interact with these data models is also important. If you need to interface with UBus in prpl OS, and then you need to interface with RBus on RDK, or if you need to do a REST API for the cloud, the reality is that you will not end up with one implementation. You will end up with multiple implementations, and it feels that they are speaking the same language, and to a certain extent they are, but it's a different development, and that's again not an ideal situation to be in. Looking in terms of the building blocks, I mean, essentially, of course, this is an oversimplified picture. We are not really trying to change much things there. So we are not trying to introduce completely new concepts. We are just trying to say the message is your system will remain the same. The system bus will still be the same. Your services, your components will still remain the same. The difference is that now you are introducing some software glue or something in common with other software stacks so that your applications can interact with the system regardless if it's RDKB, if it's prpl or something else. So you need to have something in common, otherwise this not works. And really what we are doing is putting the USB agent out there, becoming that broker, that entry point from the gateway, regardless if it's just for remote management or a remote application, but also for local internal communication. And applications at the end of the day just become just USB endpoints or application or services. Let's call it this way. Maybe just I realize that when we present a slide like this, that we get a lot of questions. So I want to use the opportunity to talk about some myths, which is again like we've described in LCM. We are not trying to push anything. We are just trying to reuse existing technologies and work with everybody to solve these problems together. But there are certain things that will not change. One of the questions that we get is, I don't want to replace my system bus with USB. No, nobody is going to replace your system bus. It's going to remain there. RDK will continue to have our bus. prpl is going to keep using new bus. If you use something different, and I know that some of the companies have even other system bus, that is not going to go away. That's not going to change. And your applications, your services also do not have to be refactored. They can still be there. And perhaps the third most important aspect is, what about your backend infrastructure? Maybe somebody is using TR69 and for whatever reason they don't want to upgrade for USB, or maybe somebody using something different like WPA and the infrastructure is already there. It doesn't make sense to now invest in something different. The good news is you don't have to change any of that. You can have different protocol adapters in your system and you can take advantage of them as you want to. In fact, Broadband has already foreseen some of these use cases where one might use TR69 for provisioning and basic management, and you could just use USB for services. They have TR181 in common, so there's a lot that can be reused, and at the end of the day, it's your decision to decide which building blocks you want to use. And again, we are not trying to push for specific directions. We are giving different tools and different solutions, and then it's up for all of us to decide what to take advantage and what you do not want. But reality is, if you really want to solve all these problems, then of course some things have to be done. Now, just sharing a couple of words in terms of the activities that we are doing. There are essentially 3 pillars to the high-level API working group. We are working very closely with Broadband 4, and we had Jason Walls speaking about this. I know you are typing in the laptop. That's why. No worries, no worries. It was about the high-level API, so you are forgiven. No, but seriously, Jason Walls did a good job at describing what we are doing in USB, the work that we are trying to augment. And the reality is, we also get some concerns about this. We hear expressions like, but USB is just a remote management protocol. Okay, maybe to a certain extent it is. Maybe when it was created, that was probably the primary goal. But the good thing is that we are a community, right? We can all be part of it, we can influence it, and we can extend it to take its initial scope beyond what was initially intended. That's how we evolve, that's how we learn, and that's really the message. So for that reasons, we have 3 ongoing activities there. Just going to share a few words about that. Second comment that we get is, TR1U1 lacks capabilities necessary for internal services. Maybe, I don't know, you're missing, you can see that a lot of these data models are based on configuration. It could be that you need more commands, it could be you need more events, it could be that you need new services, and that's just fine. Standardization needs time to add these things, and the reality is David Cluytens has been putting really a lot of effort. I cannot reinforce how much he's doing behind the scenes that all of you are not seeing it, but he's really putting out there and trying to really make TR1U1 compliant and enable for internal services. And I invite you, all of you, to be part of this and to support him. If you see something missing, reach us out. We will more than happy like to have a discussion. Sorry, I'm just skipping one slide. Lastly, I already discussed about the application developers don't like data models. We get, not sure if everybody's familiar with this, but we get this comment a lot because of the problems that I already described. So again, we don't have something already available today, but we are working and we have on the horizon some efforts to work on application SDK where we can enable these data model driven applications to be created more efficiently. So we are trying to provide a migration path, and we are also trying to provide some code helpers to even generate some automatic code and so on. A couple of words on the USP initiative. So some of you might be familiar that USP offers multiple message transport protocols like WebSockets, Stomps, and MQTT, and these are good at remote management. They enable different use cases. But when you look at constrained devices like CPEs, you really want to make sure that you are optimizing those communications. And the reality is there's a lot of overhead in these protocols that you can, but you don't need to when you have something running inside your CPE. For that reason, we are working on an internal MTP which simplifies the communication, eliminates some of this overhead so that USB can scale and adapt to more applications running inside the CPU. So that's one addition that we are working there in BBF. Second aspect is data model decentralization. USB agent allows for different controllers to interact with the system, but that's mostly for interacting with the data model, not actually like doing gets and sets, not actually extending the data model. If you want to extend the data model, you usually need to do it on the system bus, or you need to do some integrations with the protocol adapter itself. So we are working with BBF to add some, I'm not sure, I need to be careful with the words. Some of these things are still being discussed. I want to be fully honest about that. That has been mentioned. Has been mentioned already, but essentially in practice we are trying to add some brokering capabilities. So if your application also has some data models to offer, you can do it through USB. You can say, look, I'm maybe a parental control service, and maybe there are some rules to be added, and this application can just hook to the USB agent and say, please make these data models available to the other controllers as well. So that's the second ongoing effort. On the security side of things, and one of the reasons why USB was also an interesting framework to this is that it already supports access controls, right? It has now I'm missing the right word, but something like role-based trust, role-based access controls. Thank you very much for this. So that means that you can limit how much these applications can access. But we need to do the same for an application offering its data models. Imagine that you are putting a speed test in your device, right? Maybe that speed test application needs to put some data models to read the results of the speed test, maybe some commands to trigger the speed test, but you definitely do not want that application, a speed test, to advertise itself as the one that has some Wi-Fi capabilities, because that's actually a security breach. Spoofing is common, and we need to find ways to mitigate that. So that's a discussion that we are also having in BBF. Now, I'm going to hand over to David Cluytens, which is the man that has lately been really doing the heavy lifting. I hope you get a prize next year, David, for all of the effort. And if you can just talk a little bit about the ongoing efforts in TIA 181.
Thank you, João, for the introduction. Over the past few years, we really took the microservice concept to the next level. Me and my team, we did a thorough investigation of what it's needed, looking at prpl requirements, looking at our own experience, and we gathered all that and we extended the Tier 181 data model. So thanks to Jason and João, very nice fellows to work with in the BBS bus working group, and of course Chris, my compadre, also. So I'm not going to call out all the work that we did over the past years, so I'm going to take a few examples. So one of the examples was that all the modern gateways, they have now an XPON interface, one-access interface, and when you look at Tier 181, you will find nowhere a decent one data model. So we worked together with the BBF bus working group over the last year in trying to make this a reality and having this new XPON object available in Tier 181. In the prpl OS Foundation, there was also a working group about creating a QoS prpl manager. And out of one of these requirements came that in BBF, in the Tier 181 data model, we are actually missing the concept of a hierarchy for queues, schedulers, shapers. So we worked again with them to add these concepts to the data model. So here's an example of a complex QoS scheme that you can have in your router. Data model to control it, and how we did the hierarchy. Another example is we have, over the last few days, seen a lot of LCM demos here on Broadband World Forum, here on the prpl Summit. Chris did a lot of work in having this in Tier 181 so that everybody in the community has a standard way on controlling these applications. One of the things that was missing, for example, was setting constraints on the CPU and stuff like that. So we worked with a working group to add all these things to the data model. So what's next on our roadmap? I can assure you that we are not yet finished, far from that. So what we have is, for example, we need to add some firewall concepts that we need to discuss and get them in. On the statement of work, you have PCP and DS Lite that we need to investigate and see if we need to add new things. We need to provide more documentation in the form of theory of operations in Tier 181. I think Chris will have its hands full also next year with extending the software modules framework object. And of course, the IMTP. We would like to have the IMTP in straw ballot this year so that it can go in the final spec. So that's for us really, I think, as a high-level API working group, if we could achieve that, it would be a nice reality. So where can you find all these fun stuff? So I put up a few links, so the ones who are interested and who will be receiving the slides, they can knock themselves out and clicking on the links that we have provided them as feedback.
Thank you very much. That pretty much summarizes our discussion. Unfortunately, we don't have a demo to show today, but as you can see, there are a lot of efforts ongoing, and we hope that perhaps next year we'll be in a better position to start demoing all these things. So again, big thanks to everybody, including yourself, David, for being part of this journey, for contributing, challenging, because challenging is also important. We embrace people challenging us because that's what really help us to see through our realities, to try to see things from an end-to-end perspective. And we believe, like Wojtek, David, and other people also described, that's what really drives this community forward, and that's really what makes us successful. We definitely do not want to blind ourselves with not seeing beyond all of this. So thanks, everybody, and I hope to see you in the working group.